27, and 30. Now, C union D complement becomes those integers that are not in C union D, but they are in the universal set. And they are those elements that are not there. We have 10 here, 11 was omitted, so we put 11 here. 13, 14 is not here, so we put it in here. Good day, my audience. Well, we are going to look at a question under set theory. We have one question here on the board. Let's read the question. It says, if sets epsilon, that set, let's call it E or epsilon, is the universal set, and sets A, B, C, D are subsets of E, such that E is equal to X, such that 10 is less than or equal to X, less than or equal to 30. A is equal to X, such that X is prime. B is equal to X, such that X is even. C is equal to X, such that X is a multiple of 3. D is equal to X, such that X is factors of 30. List A, the question A says, list all the elements of sets E, A, B, C, and D. B, find I, C union D complements or complement I, A intersection B intersection C intersection D. I, B intersection C in union to C intersection D. Okay, IV, A union C minus B intersection D. And finally, A complement intersection to B complement intersection D. Now, we are going to solve this one after the other. First of all, the first one says A lists all the elements of E, A, B, C, and D. Now, this set came in form of what is called a set builder. In set builders, we use inequalities to represent the elements of the set. The set says that X is, the set E is equal to X such that 10 is less than or equals to X is less than or equals to 30. Now, from here, we know that X is an integer. X being an integer, we know that the elements from X being an integer, we can now say that the elements of the set E are those integers from 10 to 30. So you have 10, 11, 12, 13, 14, dot, 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 up to 30. These are the elements of the set E. Then the elements of the set A are those integers in this set E, in the universal set, that are prime numbers. Those integers in the sets, in the universal set, that are prime numbers. They are 11, 13. By the way, prime numbers are numbers that have only two factors, itself and 1. So we continue 11, 13, 17, we have 19, we have 23, we have 29. These are the prime numbers from 10 to 30. B are those integers that are even numbers from the universal set. The even numbers from the universal set are 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. Okay? The next one are those integers that are multiples of 3 from this universal set. The multiples of 3 from the universal set are 12, 15, 18, 21, 24, okay, 27, and 30. And finally, we have those integers for D. We have those integers that are factors of 30. Integers that are factors of 30 are 10. From this set, we have 15, we have 20, and we have 30. So these are the sets. These are the sets E, A, B, C, and D. Now we go ahead here. I'm going to use this part of the board. We go ahead to find for B, I, we're going to look for C union D, all complement. First of all, how to solve this is to first of all look for C union D. Solve what is inside the bracket. C union D are elements that are in C and D. Write them down without repetition. All the elements in C and D. So we start with 10. We have the elements 10. We have 12. We have 15. 10, 12, 15. We have 18. We have 20. We have 21. Okay, we have 24, 27, and we have 30. Okay, that is 12, 10, 12, 15, 18, 20, 21, 24, 27, and 30. Now, C union D complement becomes those integers that are not in C union D, but they are in the universal set. And they are those elements that are not there. We have 10 here, 11 was omitted, so we put 11 here. 13, 14 is not here, so we put it in here. 16 and 17 is not there. Bring it in, 19 is not there. It's not in the set, so it should be here. We have 22 and 23 are not there, so they should be here. We have 25, 26, which are not there, should be here. We have 28, we have 29. Okay, so this is C union D complement. Now the next one is A intersection B intersection C intersection D. That is what A, B, C, and D have in common. Now let's look at it. From there, this one is a prime number. Prime numbers are not here. What are here are even numbers. So A intersection B is empty. This one is factors of 3. The factors of 3, you can't see factors of 3 in A. In B, there are few factors of 3 here, like 12. Then C are factors, okay, these are multiples of, C is multiples of 3, and D are factors of 30. But because that there are two sets here that are empty, their intersection is empty. A and B doesn't have any intersection. So because of that, the whole of this intersection is going to be empty. Just A and B have nothing in common. Because they have nothing in common, it has failed the condition of intersection. So I believe that what we have here is the empty set. Empty set. There is no intersection because this set and this set have nothing in common. So in the same way, since they have nothing in common, it will affect the other sets. There is nothing in common between the 4 sets. Okay, we have, let's say, B intersection C union C intersection D. First of all, I'm going to take B intersection C. B intersection C, we have 12, okay, we have 12, we have 18. What is common between B and C is what I'm taking. We have 12, 18, we have 24, okay, and we have 30. Then C intersection D is what is common between these two, which is just 15 is there and 30. Now, the union of these two, because they are asking us to take the union of this and this, so B intersection C union C intersection D becomes what is combine all the elements here without repetition. We have 12, we have 15, we have from there 18, we have from here 24, and we have 30. So this is what we have from B intersection C union C intersection D. Now I will go ahead to solve for, permit me to clean here, I'll go ahead to solve for the next one. 11, 12, 13, 15, we have 17, 11, 12, 13, 15, 17, we have 18, 19, 19, we have 21, 23, 21, 23, we have 21, 23, 24, 27, 29, 24, 27, 29, and then 30. Okay, the next thing is to take B intersection D. B intersection D will give us what is common between B and D, and I think it is 10 and 30. 10, 20, and 30 is common. 10, 20, and 30. Let's check it out. We have 10 here, we have 10, we have 20 here, we have 20, we have 30, and 30. So that is B intersection D. Now we now take everything together. A union C minus B intersection D. Now how we solve difference is to get the elements that is common between these two from the set already listed. From the set already listed, I'm going to get the element that is common between them. What is common between this is 30. 30 is the only element common between this and this, these two sets. So that 30, which is the only element common, we subtract it, we remove it from the first set and write down whatever that is left as our result. So if I remove that 30 that is common from the first set, I will have 11, 12, 13, 15, 17, I have 18, I have 19, 21, 23, 24, 27, 29. I omitted 30 because 30 is common. So you subtract the 30 from the first set to get the difference. Now the last question there says V, A complement intersection, B complement intersection D. Now the first thing I'm going to get now is A complement. And A complement means those integers that are in the universal set but are not in A. They will comprise the element of A complement. Those elements that are in the universal set but not in A will comprise the elements, the set A complement. So A complement, anything I am not seeing here, but I see it here, I'll write it down. That is 10. 10 is in the universal set, but it's not here. I have 12. 12 is not here. Now I have 14. I have 14. I also have 15, it's not there. I have 16, which is not there. Now I have 17, so I won't write it down. But 18 is not there, so I'm going to write it down. I have 19 already, so we are writing 20, 21, 22. We have between 23 and 29, we have 24, 25, 26, 27, 28. We have 29 there, so we omit it and write 30. Now, this is what is in A complement. Let's go ahead to look for B complement. B complement is those elements that are in the universal set, but you can't see them in B. They are 11, 13, 15, 17, 19, 21, 21, 23, 25, 27, 29. This is B complement. Now, the bracket there says take B complement intersection D. So the intersection of B complement intersection D is simply what is common between B complement, this new set, and our already existing D. Okay, so we have 10, 15, 20, 30, and I cannot see 10 here, but 15 is there. I can't see 20 and 30. So the only thing that is common between B complement and D is just 15. It's just 15. So we now go ahead to look for A complement intersection B complement intersection D. So what is common between these sets containing 15 and then A complements? Yeah, we have 15 in A complement and B intersection D contains only 15. So the common element between the two of them is that number 15. So we have 15 as what is common between A complement and B complement intersection D.